Hello everyone. My today's video is on bias variance trade-off in reinforcement learning, Monte Carlo versus temporal difference. We investigate bias variance trade-off in reinforcement learning. My name is Yousef. Here you see the outline. We start with Monte Carlo method, then continue with temporal difference method, and discuss about bias and variance and finally present the key points. Let me highlight that both Monte Carlo and temporal difference are using reinforcement learning to estimate the value function. Okay, let us start with Monte Carlo method. Monte Carlo method in reinforcement learning involve learning directly from complete episode of experience. This method waits until the end of the episode to update the value function, ensuring that the estimates are based on the actual return observed. Okay, the idea is that in Monte Carlo, we wait until the end of the episode, then compute the return. In Monte Carlo, the return is computed using the following formula: is discounted sum of the reward. Please pay attention. Return is computed as a discounted sum of the reward. Okay. But temporal difference method, temporal difference method in reinforcement learning combine the idea from Monte Carlo method and dynamic programming. They update the value of a state based on the estimate of return, using information from the next state and reward observed. Okay, and I think this is clear. Unlike Monte Carlo method, temporal difference method update the value function after every step. This is the key point. As I discussed it, in Monte Carlo, we compute the return after the end of the episode. But in temporal difference, we update the value function after every step rather than waiting for the end of episode. Okay. In TD method, instead of waiting until the end of episode, the target is computed using the following formula: is the sum of the immediate reward and the estimate of the future reward. Bias. Before discussing bias on Monte Carlo method and temporal difference, let me tell you what is bias. Bias is assumption. As bias is assumption that we made about the target function. Okay, actually, is a simplifying assumption that we made about the problem. We call this a bias. When we say low bias, we mean we have a few number of assumptions, and when we say high bias, we have a high number of assumptions. In Monte Carlo method, as I discussed, we compute the return as the discounted sum of the reward. There is absolutely no assumption, no simplifying assumption here. We wait until the end of the episode and then compute the return. There is no assumption here. That's why we say that the target value, GT or return, is an unbiased estimate of the value function. Okay? So the target value is an unbiased estimate of the value function, and we don't have any simplifying assumption here. But what about temporal difference method? The TD target is computed using the following formula: immediate reward plus future reward. Okay, uh, reward and next state are unbiased since they are sampled directly. I think this is clear. However, this value function is the estimate. Okay, this is the estimate. We have a simplifying assumption here. In every step, we estimate the value function. Okay, that's why we say that TD method is biased. Okay, we have a simplifying assumption. We estimate the true value function. Okay, as you can see here, the value function is the estimate, not the true value function, and that's why the bias is introduced. Okay, so let's summarize. Monte Carlo method is the unbiased method. We don't have any simplifying assumption here, but temporal difference method is a biased method due to the role of this value function and the way we compute it, we estimate this value. Variance. Let me share with you what is variance. Variance means for different input to a function, we receive different output. Okay, for different input, we receive different output. In Monte Carlo method, as I told you, the return is the sum of all reward until the end of the episode. Okay, uh, uh, for one for so imagine for one trajectory the return is the sum of all reward, and another trajectory is also sum of all the reward, because the number of involving parameter, the number of involved reward function is high. We have a variance here. Okay, so we can say that Monte Carlo method has a high variance. Let me restate again. For different trajectory, we can have different return value. Okay, why we can have different return value? Because it's depends on too many parameter or reward function. Okay, but temporal difference method has a lower variance in comparison to the Monte Carlo. I think if you look at this formula, the idea is clear. The TD target only depend on the immediate reward and the estimated value. It's just function of two variables. Okay, lower variance compared to Monte Carlo because fewer variables are considered. Okay, so to summarize, Monte Carlo has a high variance due to the high number of parameters involved in computing reward. For different trajectory we have different return, and the PD method has also variance but has a lower variance because it just depends on the reward and estimated value. Key point. Monte Carlo target are unbiased as discussed, but they have a high variance. Okay, but TD target have lower variance in comparison to the Monte Carlo, but they are biased due to the estimation of the value function. The bias in TD method decrease as the value function estimate improve over time. Thank you very much for your kind attention. If you learned something from this video, I appreciate to like and subscribe. Thank you very much.